to physics and mathematics lovers. Today we want to look at a topic in mathematics, and the topic says, well, mathematical induction principle. All right. Before us here is a question, and the question says, using mathematical induction principle, prove that the following statements are true. We have 1 all over 1 times 2. This is a dot product, okay? Stating as what? 1 times 2 plus 1 all over 2 times 3 plus 1 all over 3 times 4 plus dot plus 1 all over what? N into what? N plus 1 equal to what? N all over what? N plus 1. So now when we look at, we'll talk about mathematical induction principle. It is used to test mathematical theorems and statements to check whether it is true or false. So sometimes formulas may be denoted for a particular statement. So we use mathematical induction to check whether it is true. Now, basically, mathematical induction is based on what? 3 steps. The step 1 is what we call what? The inductive what? Base. This inductive base, or you can call it what? Base case. It means when you substitute, we say when n equal to 1. It means that we check whether the statement it is true, whether the right hand side tallies what with what? The left hand side, whether it tallies with the right hand side. So you substitute n equal to 1. So when you put equal to 1 and if it is true, that is to say, if I place 1 in place of n, wherever I see n, I put my 1. If it obeys the statement, it then means that what? The statement what? Holds. Then the second step we are going to look at, second step is called the inductive hypothesis. This is inductive hypothesis. So here, this is where you say let n. When you say let n equal to k. So k is the next term of the series. When you look at this now, this is a series or sequence. It means that it obeys a particular what? Formula, which is this. This is what is used to obtain each what? Term by what? Term. Are you getting it now? So this second step, we have to determine what will be the next number that will come after this particular what? Term. So which is the major reason they put this here. So in this case, you're going to plug in what? K, wherever you will see n. So that is where we have what? The inductive hypothesis. So the last step we are going to look at, which is number 3, we call it what? Inductive step. Inductive step. This inductive step is where you assume, and in this case, we have already assumed that what? When n equal to k, it is what? True for the what? This what? Statement. So in this case, you're going to say when n equal to what? K plus 1. Yes, for all set of what? Real integers or natural numbers. So for us to get the next term after the k term, it has to be what? K plus 1. So this is the inductive step where you check if this particular statement holds or if it will hold for this particular statement. So that is what we will be looking at now. So having this one in our mind, let us apply it here. If we can be able to arrive at what? A precise what? Answer or required what? Answer. So let's check if this statement is true. So let's go. Now, so for us to solve this now, we can say let P n be the given statement. So let Pn be the given statement. Yes, it means that whatever I'm going to look for, so n now represent, if I want to take when n is equal to 1 now, when n equal to 1, I am going to check if what is on the right side, this right side will be what? Equal to this what? Left hand side. So if that is true, it means what? The statement is what? Correct. So now let's go. When n is equal to 1, that means that what? we then have our what? P1. Our P1 now is where we are going to take what the first term. That is what n equal 1. It means what the first term here, which is this one. So it must obey this formula. So let's work now. So P1 now will be equal to. So remember that here we have 1 all over 1.2. That is dot product. It's not points. So 1 times 2. Then on the right hand side, you're going to plug 1 for n, which means 1 all over what? N plus 1. Okay. Okay, n, it's become 1. Okay. It's not n again. You replace n with what? 1. So at the end of the day here, 1 times 2 is what? Is what? 2. It implies that what we have on the left side, 1 over 2. Then here, 1 all over what? 1 plus 1 is equal to what? 2, which means 1 over 2. So it then means that what this statement is true whenever n is equal to what? 1. So P1 holds. So let's go to the second proof, where we have to assume that what? N equal to k is also true. So that is where we have n when n is equal to what? K. So if you try to also, it's going to give you exactly the same thing. So instead of doing that, I just have to what? Skip that. Instead of saying when n is equal to 2, n equal to 3, at the end of the day, it will still give us exactly the left hand side must always be equal to what? The right hand side. So which is why I'm going to be moving further to this next step, which is what? The inductive hypothesis. What you do now, we said that what? We want to know the next term that will come after this. So which means wherever there is n, I am going to plug in what? K. So wherever I see my n in this what statement, I am going to plug in what? K. So we start by what? Going by saying here, the first one here we have what? 1 into 1 times 2 plus 1 all over what? 2 times 3 plus 1 all over what? 3 times 4 plus dot 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 dot. Then here plus this case now we are going to put what? 1 all over. In place of n, we said that when n is equal to k. So you put k into what? Inside here we still have an n, which means k plus 1. Then equal to, move to the right hand side, we have n over what? N plus 1, which means I am going to put my k plus k all over what? K plus 1. So as you can see, this statement is true for when n is equal to k, because it obeys exactly what is here. Okay, so we assume that what? N is equal to k is true. Right. Therefore, we move further to the last step. We're going to have that, which is the last step, the what? Inductive step. So that we say, well, when n equal to k plus 1. So we are going to plug it into the formula of the expression or the statement that we want to check. What we do now, which means our p k, remember we say p be the statement, pk now will be equal to, here the whole of the sum we have here 1 all over what? 1 times 2 plus 1 all over what? 2 times 3 plus 1 all over 3 times 4 plus dot 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 dot. Then we have our k term is this, which is 1 all over what? K into what? K plus 1. Then plus the next term we are going to have, which is this our what? K plus 1 term. So we are going to plug it in that our formula for deriving the next term, which is what? 1 all over what? N is what? Which is this one, which is what? 1 all over what? N into what? N plus 1. So here in this kind of thing now, what we do now, just plug in k plus 1. So here we are going to have what? 1 all over what? K plus 1. Then plus this one is inside the bracket. We are going to have k plus 1. Then there is 1 already here, plus 1. Then equal to, we move to the right hand side. Remember the right hand side formula is where we have n all over what? N plus 1. So that is the right hand side. So in place of n, you put your k plus 1 there. It becomes k plus 1 all over what? Here we have k plus 1, then we have 1 there already, plus 1. So we move. Now let us look at so here, what you do now, remember we said that it is a summation of all these ones that we have to obey the right hand side. So to determine all this one, at the end of the day, when you add all of them, it's going to give you the right hand side. So in this case, what you have to do now, remember, when I said let n equal to what? K, the summation of the real integers or the natural numbers from there to here gave us a value which is our what? K over what? K plus 1. So in this case, we are going to replace the whole of this place now, what? With this, which is a k over what? K plus 1. So it is the summation of all these ones that gave us this. So in our second step. So whenever you are carrying out this inductive proof, you must always bring out what value you have for the second step to replace the whole of the series from here, the sum of them. So which means in this case now, I am going to have my what? K all over what? K. Look at it here. K plus 1. You have to be very careful in doing this. Then plus the next term. Look at the next term here, which is what? Term K plus 1. You bring it there. Then plus, we have 1 all over. Then you have K plus 1 outside the bracket plus 1. Then inside this bracket here, you have to distribute here. Look at here. We have 1 here. Open this bracket. Remove that bracket. We have 1 here. 1 plus 1 here will give us what? K plus 2. Equal to, bring out the what? This side. Bring it down. We have K plus 1 all over. So here, in this place now, we have K here. Then there is 1. Remove this bracket. It becomes 1 plus 1. We have a K plus 2. Alright. So at this point now, this is where you carry out your algebraic simplification. So because our interest now is to make sure that what? The left hand side must be equal to the right hand side. So at this point now, I will what? Ignore the right hand side. I will walk towards the left hand side to make sure that I obtain something like this. That is just the basic concept of mathematical induction. So what will I do now? Here and here, I'll have to take the LCM. The LCM between all this one is this K plus 1 equal what? K plus 2. So what we'll do now, I will take the LCM. The LCM is what? K plus 1 equal what? K plus 2. Then when you go there, this one goes here, it will cancel this one out. It will remain this. Use it to multiply here. We're going to have K equal what? K plus 2. Then this one will come here. It will cancel out. Use it to multiply. This one cancel out 1. 1 times 1 is what? 1. We have a plus 1. Then equal to what? Bring your right hand side. Bring it down. Don't touch there. Plus 1 all over what? K plus 2. So the next thing now is to what? Distribute this our what? Bracket here. Let us distribute it. So distributing that, we're going to have K times K gives you what? K square times 2. K times 2 gives you what? 2K plus 1. Alright? Then all over. We have K plus 1 over what? K plus 2 equal to your right hand side. So bring it down. Your right hand side is K plus 1 all over what? K plus 2. So at this point here, you have that K squared plus 2K plus what? 1. So this will now take you to the knowledge of factorization in algebra. So we have to factorize that up because our interest here is working towards what? Obtaining the right hand side so that what? We maintain what? Parity. So now let's go. What you do now, let us factorize this. Factorizing this, remember in our factorization by grouping, you take this K here to multiply this one. It means that is sum. That is the product rather. 1 is the product. And the middle here is the sum, 2. Meaning that what, if I have two numbers that I will multiply together, that will give me 1. Then when I add the two of them together, it will give me what? 2. Which means we have 1 times 1. 1 times 1. Then 1 plus 1 is equal to what? 2. 1 times 1 is equal to 1. So remember in algebra, we use numbers, we use letters to represent what? Numbers. So this means this will give us K and K. K and what? K. So in place of this 2K, we are going to replace it with what? K plus K. So which means we are going to have K squared plus K plus 1 all over k plus 1 e to what k plus 2 equal to, now bring your right hand side, bring it down, k plus 1 all over what, k plus 2. So here we factorize by grouping. K is common here, k is common here. Then you take one of the k out, we have k. Then we are left with 1k there. Then if k is out, here remains 1. Then what is common between this one and is 1? We have plus 1. We have what, k plus 1. Then all over what, k plus 1 e to what, k plus 2. So what you do now, bring this right hand side, bring it down. So is equal to what, k plus 1 all over what, k plus 2. So the next thing you do now, let us look at it. This one is common here. 1k plus 1, k plus 1 is common. So you just take out there, you discard one of the brackets. So now we have k plus 1 e to k plus 1 all over k plus 1 e to k plus 2. They're equal to the right hand side, k plus 1 all over what, k plus 2. So at this point now, we can see that what is here we cancel out. So let us cancel out. Now doing that, this one we strike this. So here we now have k plus 1 over what, k plus 2 equal to what, k plus 1 over what, k plus 2. So as you can see, our left hand side is equal to what, right hand side. So in our conclusion, we then say that what, this statement holds, and the statement is what, true for the sum of all natural numbers. So it means that what, p k plus 1 holds, and it is true, and what, true for the sum of all natural numbers. So if you find this class very interesting, please do not hesitate to share this video to extend this knowledge, and also subscribe to our YouTube channel, Physics and Mathematics Lovers. God bless you. Bye.